So just as a quick warm-up to remind us where we left off last time, we derived the equation of a circle from the distance formula way back at the beginning of our semester. And so what I would like you to do, just to review, is I've given you the center and the radius of a circle. I just want you to take a moment. I'm going to give you about 60 seconds, and I want you to write down the equation of the circle with the given criteria. Okay, so the center radius form of a circle is given by this. This is what we saw last time, and so this is what we see. It is x minus h, which is the x coordinate of the vertex, and this is giving me some. There we go. Okay, which is the x coordinate of the vertex plus y minus k, which is the y coordinate of the vertex, is equal to the radius squared. So hopefully what you did is you remembered that, and you just plug and chug. You put the appropriate value in the appropriate place. So what do I have with my x's? I have x what? Yes, that's beautiful. X minus 10 squared plus, and then y, and then what? Yep, plus 5, because we're subtracting a negative 5, so plus 5 squared is equal to r squared, and the radius is 11, so that's 121. So this is called right here, this is the center radius form of the circle. Okay, so called because you need the center and the radius. It's kind of like slope-intercept form of a line. It's called that because that's exactly what you need. So here's the thing though, not all circles are given in that format, and I still want to know what the key characteristics are. So I'm going back to page 2 where we left off, and here's my next example, example 3. I've given you an equation of a circle, and this equation of the circle is given not in center radius form. This one's given in standard form. Now, you always know it's a circle. We are only talking about circles in here. We're not talking about parabola, ellipses or hyperbolas. So this is how you know. I'm not going to trick you on the test, but I do know that there's one homework problem that lists a bunch of equations and asks you which ones are the circles. Here's how you know that in front of your x squared and y squared, you have the same positive number. Okay, so always in front of the x squared and in front of the y squared, the coefficients are equal and they're positive. So if one of them's negative and then you have what's called a hyperbola. If they're both positive but they're different, you have what's called an ellipse. So we're not talking about those things. So just know if those coefficients in front of the x squared and y squared are equal and positive, you have a circle. And so what I want to do with this problem, and then you're going to do one, and that's how we're going to finish off this worksheet in this section, is I want to be able to take the standard form and I want to put it in, into center radius form. We're going to do that by a process. We've seen this process before. In fact, the last time we were in section 3.2 and talking about parabolas, we did what's called completing the square. And we're going to do it again to take our standard form and we're going to put it in center radius form. So just like we did back then, what we're going to do first is we're going to group our x's. This time, though, we have y's. We're going to group our y's. We're going to put the other number on the other side. So here's my first step. Step 1, I'm going to put a parentheses around the x squared minus 6x. I'm going to leave a little space. And then I'm going to put a parenthesis around the y squared plus 10y. I'm going to leave a little space. And then that plus 25, that's right there, I'm going to put it on the other side. I'm going to subtract it, and so I have minus 25 on the other side. That's always step one. Group your x's, group your y's, put the extraneous number on the other side. So far, we so good. Anybody got a question about what I've written on the page and where anything came from or anything like that? Don't be shy. There's only like 9 of you here today. So apparently everybody took a sick day today from college algebra. I don't blame them. Okay, here we go. Here's the completing the square step. This hopefully sounds familiar. What do I do with this middle number? Does anyone remember what I do with this to complete the square? You take half of it. Beautiful. What's half of 6? 3. And then what do I do with that 3? You square it. So I'm going to put a plus 9 right here. Now, if you remember, when we did this with parabolas and we were dealing with functions, what we then did is we added 9, and then outside the parentheses, we subtracted 9. But in this case, since I've got a circle, because it's not a function, I have both sides of the equation available to me. Since I added 9 over here, what do you think I'm going to do over on the other side of the equation? Not going to subtract 9. I would do that if I was doing it on the same side. But to keep the equation in balance, I'm going to add 9, yes, to both sides. Then what am I going to do to both sides to complete the square for the y's? Add 25. Where did the 25 come from? Tell everybody. Half of 10 is 5. Square it is 25. Beautiful. Well said. I appreciate your help. So I'm going to add 25 to both sides. Before I go on and finish this problem, does anyone have, did I lose anyone on that step? Are we okay? Do you see why we added the same thing to both sides? Okay, we have no reason to lie to me. We're all friends here. It's almost the end of the semester. So now when I go ahead and do my factoring, the two factors of 9 that add up to -6 are x minus 3 and x minus 3. So I have x minus 3 squared. And then the two factors of 25 that add up to positive 10 are y plus 5 and y plus 5. So I have y plus 5 squared. And then finally, when I add up the numbers on the other side, negative 25 plus 9 is negative 16. Negative 16 plus 25 is 9. And what I was asked to do is to identify the center and the radius of this. Okay, so tell me, what is the center? This is what we did last time, so this is kind of review. What's the center of this if I just gave you this equation? 3 is the x value, and then minus 5 is the y value. Thank you very much. That was great. And then what's the radius of this circle? Okay, this 9 represents the radius squared. So I take the square root of that, and so that becomes 3. Because the format of my, I'm going back to page 1, when we derived the formula for the circle. Okay, when we did the distance formula, I squared both sides to get rid of the square root. And so that means that that number on the other side is the radius squared, the distance from the outside of the circle into the center. So yes, so that 9 is the radius squared. And so I take the square root to get the radius. Better? All right, do the same thing for exercise 4. Should work out to be pretty decent as well. Although I did throw in a little review of simplifying a radical on that one because that pops up on the final exam. To get started, if any of the steps that I do here confuses you or you have a question, please be aggressive, ask whatever you need, leave here feeling nice and solid. I want this last test grade to be amazing for you. So first thing I'm going to do is I'm going to group my X's and I'm going to group my Y's. I'm going to leave a little space. And then I'm going to take that 25. I'm going to put it on the other side by subtracting it. And that becomes negative 25. So far, are we so good? And anybody bothered yet? I'm trusting you to let me know, okay? So now, what am I going to add in this parenthesis right here? 16. Half of 8 is 4, and that's 16. So that I'm going to add 16 over here on this side as well. What am I going to add in this parenthesis to complete the square? Yep, half of 12 is 6, squared is 36. So I'm going to add 36 to both sides. Great job. Thank you for your help on that. So now x squared plus 8x plus 16 becomes what squared? Beautiful. Thank you for your boldness. I love it. X plus 4 squared plus, and then here, y squared minus 12y plus 36 becomes what squared? Yes, that is great. Y minus 6. And then when I add these numbers up, negative 25 plus 16 is negative 9. Negative 9 plus 36 is 27. You got that? You've done fantastic. The center. What's the center of that circle? That's true. Negative 4, positive 6. That's the x and the y value. The radius is going to be the square root of this. And this I kind of mentioned at the beginning. This is just a quick little review of simplifying square roots. So it's the square root of 27. Well, we want the exact answer. Don't put that in your calculator and tell me 5 point something. I'm not interested. So what I have to do, though, is use the product rule of radicals. 27 has what factor that is a perfect square? Yep, 9. 27 is 9 times 3. So my radius, when I do that, what's the square root of 9? That's 3 without a radical. It's outside the radical. The other 3, that was part of the factor of 27, stays under the radical, and there's your radius. Wanted to make sure to put 1 on there just because if you hit it on the homework or on the test or on the final exam, I don't want you to be upset with me. All right, last page about circles. I've got one more example for you to do the same thing just to get the practice and lock this into long-term memory. So do exercise 5. I'm going to get started on this one. Let me know, again, if there's questions. I'm happy to answer questions. So I'm going to group my x's. So I've got x squared plus 2x. I'm going to leave a little space. I've got y squared plus 6y. Leave a little space. I'm going to put the negative 15 over on the other side by adding it. So I get equal to positive 15. So what am I going to add in this parenthesis right here? What was that? 1? Okay, I'm just sorry. The door was closing. I was having trouble hearing. I'm old. You got to forgive me. Half of 2 is 1. 1 squared is 1. You're 100% correct. And then what am I going to add in this parenthesis right here? Perfect. Half of 6 is 3. And so then I've got to do the same thing on the other side. So I will. And so I have this first one, x plus 1 squared, and then I have y plus 3 squared. And then when I add these numbers, I get 25. So it's a pretty straightforward problem. So if you're having any trouble with this, please let me know. I'm going to throw a couple problems just like this on the test you're going to have on Tuesday, and I want you to ace those. So the center of the circle, my x-coordinate is going to be a -1. I get that from the first parentheses. The y-coordinate is going to be -3. I get that from the second one. And then the radius in this case is what? 5. All right, one more problem. Just want to give you one more circle. So notice in exercise 6, as I mentioned earlier, when the coefficients in front of the x squared are the same and positive, you have a circle. Okay. I'm not going to give you any problems on the test where they're anything but same and positive. I am not into tricks and gimmicks. That's not going to happen. But I'm going to put one like this. You have a first step before completing the square. What I want you to do, and then we'll compare notes. So I'm going to give you 30 seconds to do this. I want you to divide every term, because this messes up completing the square. Divide every term by that 3. So go ahead and do that, and then write down what you think that new equation is going to be when you divide every term by 3, and we'll compare notes. All right, so I'm going to go through here. I'm going to divide every term by 3, because I don't want to have that 3 in front of the x squared and y squared. I want to make completing the square as nice and easy as possible. So hopefully the equation you're looking at is this: x squared plus y squared. 54 divided by 3 turns out to be, what's that, 118, is that right? And then 240 divided by 3 is 80, and then 0 divided by 3 is 0. So there's the equation we all should be looking at. Anybody looking at anything different? We okay? All right, now complete the square on that and tell me what the center and the radius are, please. All right, so here's the thing about the x's and the reason that I gave this problem, in addition to having to divide by the 3, there's no other x terms, so I've just got x squared. Then I'm going to group the y's, and I have y squared plus 18y. I'm going to leave a little space there, and then I'm going to move the 80 over to the other side, and I have -80. So there's no completing the square to be done on the x squared, because there's no y, or excuse me, there's no x term added or subtracted to that, so it's set. What am I going to add in the parentheses to this one? That is true. 81. Half of 18 is 9. Squared is 81. So what that gives me is this. I've got x squared, and then I've got y plus 9, which I'll square, and then -80 plus 81 is 1. So what's the center of this? What's the x-coordinate of the center of this problem? 0 is the x-coordinate, and then not 9. Since this is a plus 9, the y-coordinate's going to be negative 9. And then the radius is the square root of this value, which is 1. All right, we're almost done. We've done a great job. We've only got one more section in our semester after this. It's not a super long section. All right, so the last problem, I just like this problem. I always put one of these on the test, so I want to make sure I do one in class because I try to be fair. Remember, we had our warm-up problem. And in the warm-up problem, I gave you the center, I gave you the radius, and then you found the equation. It was not too big of a deal. So example 4 is similar. We're going to find the equation of the circle with a center of negative 1, 7. So I've given you the center, but then I don't tell you the radius. I instead tell you a point that the circle goes through. Well, first thing I'm going to do, I'm finding the equation of the circle. So I'm going to write down my x minus h squared plus y minus k squared is equal to r squared. This is called, like I said earlier, this is called the center radius form because you need two things. You need the center, and then you need a radius. I'm given one of those things. I'm given the center. I'm not going to insult your intelligence and ask you which one I've been given. It's right there. There's the center. But the radius, I'm not given directly. What do I have to do? Can anyone tell me what I have to do in order to determine what the radius is? Well, what's the radius of a circle defined to be? The distance between the center and the outside of the circle. The distance. So it's the distance between the center and the outside of the circle. So I need to use the distance formula. So what I'm going to do is I'm just going to skip down here and do my scrap work right here below the problem. I need to find the distance between those 2 points. That's going to be my radius. So here we go, the distance. So this is a nice review of the distance formula. The distance formula is on the final exam. It's going to be on this exam that I give you because you're going to have to do a problem just like this on Tuesday. So the distance between the x's is going to be negative 1 minus 2, and I'll square that. So negative 1 minus 2. The distance between the y's is going to be 7 minus 4. I'll square that. Negative 1 minus 2 is negative 3, which I'll square. 7 minus 4 is positive 3, which I'll square. And that's the square root of 9 plus 9, which is the square root of 18. Now, we don't have to simplify that. You can if you want to, but we don't have to because when we put it into the center radius form of a circle, we're only going to square that anyway. So I'm just going to be lazy, and I'm going to leave the radius as the square root of 18. Now, if I had given you this problem right here, this is just the warm-up problem that we did about 20 minutes ago. Okay, so I don't expect that if I just gave you the information outright, you'd have much of a problem. But here I just wanted to review the distance formula. So here's my equation of the circle. I've got x, instead of minus 1, I've got x plus 1 squared. Then y minus 7 squared. And then the square root of 18, when I square it, is just 18. And there is the answer to the problem. So I'm going to leave that on the screen. You can see it pretty easily right there. I want you to do the same thing. Exercise 7 asks you to perform the same thing. Find the equation of the circle. I've given you the center, and I've given you a point the circle goes through. I'm going to get started on the problem. If you're working, keep working. I'm not trying to shame you or anything or make you think you should be faster. Just want to make sure I'm keeping things rolling. So my center radius form of the circle is x minus h squared plus y minus k squared is equal to r squared. So that's kind of a good thing to have in the memory banks. It's going to come up several times on the test. So again, I need a center to put in for the h and the k. And I need a radius. So the center, again, I am given straightforward. The radius, though, is a mystery because I'm not given it directly. I need to figure out the distance between these 2 points right here. So once again, I'm just going to skip down below and do my scratch work down here and figure out the distance between those 2 points. Distance formula says I take the difference between the x's. So I have 5 minus -3, or 5 plus 3 squared. And then 3 minus 2 squared. 5 plus 3 is 8. 3 minus 2 is 1. 8 squared is 64, and then 1 is 1. And so I get the square root of 65. Again, that does not simplify. I don't think that's that looks like it's going to be 5 times 13. So it doesn't matter if it does simplify or not. I'm just going to go ahead and put that up there because we're going to be squaring it in a minute anyway. Let me just pause because I know I just whipped through all that. Anybody stuck or lost or doesn't see where I'm getting any of these values from? I know it's been a long time. It's been 15 weeks since we've done the distance formula. So blast from the past. So then finally, again, if I gave you this right here, I think everybody would do that just fine. So I've got x minus 5 squared, and then y minus 3 squared is equal to the radius. The square root of 65 squared becomes 65. And there is my center radius form of the circle. And I'm just waiting for the computer to catch up. There it is.